Good morning. So, part two, feeding relationships among organisms. This is where we begin to talk about the fun aspects of ecology and how, well, predator prey relationships and some of the really interesting aspects of how energy moves through an ecosystem. So, we look at ecosystem structure. The big thing we want to pay attention to is how energy moves through the system. Materials will cycle, but energy will move through the system. So, how do organisms obtain energy? Obviously, we know about eating, consumption, right? But where does it enter our systems? So, we refer to plants and algae, and there's a special organism called cyanobacteria, and the diatoms, like plankton, phytoplankton is what we call photosynthesizing planktons that are in the ocean. All of these organisms are autotrophs. Auto meaning self, and troph having to do with feeding relationships. So I always think of a trough, like um, animals on a farm will feed out of a trough, and that may help you remember that when we're talking about trophic levels and trophic relationships, we're discussing feeding relationships, and it's really about movement of energy in systems. So auto, self, troph, feeder, autotrophs, or producers, they obtain their energy from the sun through the process of photosynthesis. And then heterotrophs we refer to as consumers. So I want to, right here, I see that on our presentation there's a little bit of a misconception that somehow autotrophs might get their energy from chemical compounds on the ground, and that picture there is a little misleading. So I want to just make sure that this misconception doesn't take hold. Autotrophs also, there's a specialized autotroph that exists at the bottom of the ocean and gets its energy kind of like a battery, but through chemical means from sulfur and some of the gases that come out of the vents, the sea vents. So we talked about their underwater volcanoes. And so those special chemical compounds, there's just a really one specialized system that is, we'll talk a little bit more about it later, but it's also one of the ways that we can capture energy, or that organisms can capture energy without the sun. But by and large, autotrophs are doing photosynthesis. They're, like I said, the specialized ones that do chemosynthesis are really only found in this one specialized ecosystem that we'll discuss a little bit later. So we move up from there. Producers are going to be eaten by consumers, right? And heterotrophs, hetero meaning other, and troph meaning feeder again. These are organisms that depend on autotrophs for energy. So you are a heterotroph. Herbivores are organisms that eat plants. Carnivores are organisms that by and large eat meat. Omnivores will eat plants and meat, seeds, maybe they eat fungus, lots of things. Omni meaning many. And then scavengers are organisms that will eat animals or materials that have already died. This will help keep organisms from covering the ground while they're decomposing. Scavengers will come and just eat on like a dead carcass, and that helps keep the environment clean. And then decomposers will break down dead and decaying matter, and they absorb that, but there's basically a chemical digestion process that happens outside of their body. They're not actually consumers, if you will, in terms of like they don't have like a mouth that they're chewing on things. Scavengers, obviously, they use their mouth. Like this picture of the vulture there, a vulture is a scavenger, and it will land on a dead carcass and pick at it with its mouth, and it actually ingests it and eats it. Whereas decomposers, in the picture of the mushrooms, mushrooms are decomposers. They actually basically digest things from the outside, and so then they break that dead and decaying matter down into simpler molecules that can be absorbed. And the scavengers and decomposers are actually one of the most important aspects of an ecosystem, because they recycle the nutrients back into the soil. So I know we asked you about a food chain on the test, and I thought, it gave me a chance to see that we need to we need to go back and make sure that this is very clear. So what we have here, a picture of a food chain, is a single pathway that is represented as an example. So you can see I have the autotroph there in the little, kind of looks like some kind of berry or herbaceous plant, right? And then a rabbit who's a herbivore. So the rabbit would be eating the plants. And then the carnivore, their little wolf or coyote, whatever that cartoon is supposed to represent. So a food chain is just a single pathway, and it shows the feeding relationship. I do want to point out that the arrow is going from the plant to the rabbit, and from the rabbit to the coyote, wolf, carnivore, because the arrows on the diagram, a food web or a food chain diagram, they track the energy and not the feeding behavior. And then this, we've added some level of complexity, is a food web. So you still see the same arrows. They are represented, and food web will show all of the relationships, all of the feeding relationships in an ecosystem. It's more accurate, shows that organisms typically don't have one food source, where a food chain could be considered like a one-time event. A food web will show what's actually taking place in the ecosystem all the time. And we know that decomposers and scavengers have to be part of this as well, but really anything that dies, they are going to be the ones that will pick that up. So this big bracket is one of the ways that you can show what decomposers or scavengers are found in a food web, in a particular food web for a specific ecosystem. So to sum it all up, I got some new terms to work on: autotrophs and heterotrophs, scavengers and decomposers. They obtain energy in different ways. Food chains show a feeding relationship among organisms and can be overlapped into food webs. So make sure that you really kind of work with these words. They're going to come up a lot, and you need to have a very clear and solid understanding of how to use those terms. So all the little things that I said in my lecture, those are great for adding on into your notes. We have some extra examples. The chemosynthesis is a word, photosynthesis is a word that you could add to your notes. Auto meaning self, hetero meaning other, troph referring to feeding, that scavengers actually consume, and decomposers use chemical breakdown on the outside of their body. Those are all things that you can add into your notes. Highlight, interact with your notes, really dissect what you're doing, get a good understanding. And I know the picture on your notes is not very clear, but these are the pictures here, so you could do a little sketch on the part that's really light. All right, guys, have a good one. Take a moment to process those notes, get a stretch break in, and I hope you have a great day.